All right, we're going to go over problem number 29 of the Geometry Common Core exam from 2017. If you look at this problem, it's one of those proofs that everybody hates doing, but it's actually a pretty easy proof as far as proofs go. So let's look at it. It says in the diagram below, side GI, or segment GI, is parallel to NT. And IN, so segment IN, that's this one, intersects GT at A. So these lines intersect. All right, now, you have to think about this. First of all, okay, and what are we trying to prove? That's a very good thing to go over. We are trying to prove that triangle GIA, which would be this one, GIA, is similar. This means similar, all right, to triangle TNA. Okay, now, two ways, or actually three ways that we talked about proving triangles similar. Three main ways. So I want you to write these down. If you can prove that two of the corresponding angles are congruent, that's known as AA, or angle-angle. SAS, side-angle-side, we talked about that. You have to prove that two corresponding angles have the same ratio, two corresponding sides have the same ratio, and that the in-between, sometimes this is called included. It's got to be the angle in between, though. It can't be the other angle. It's got to be the angle in between the two corresponding sides that have the same ratio. All right? The angle in between corresponding angles are congruent, all right, to each other. And SSS, which is prove that all three pairs of corresponding sides have the same ratio. So let's look at this information that we have. It says that GI is parallel to NT. Well, they tell you that for a reason. So I'm going to label this. Remember, you can say, you can mark your picture with those little arrows to indicate that they are parallel. Whenever you have two lines being parallel, you need to start thinking about alternate interior angles, corresponding angles, okay? And those are all congruent if you have two parallel lines cut by a third line. All right? So I'll start off, and I would write the given information first. So let's write statement, reason. So let's write all the given information. So we could write that GI is parallel to NT. And that IN intersects GT at A. And that's all given. All right, now let's look at our diagram. If we know these two lines are parallel that I drew, they have these arrows, then we know that angle G is alternate interior with angle T, which means that they are congruent. All right, so we can say that angle G is congruent to angle T, and that's alternate interior angles, alternate interior angles congruent. And so then we have these two. Now we could say angle. Now, when you have two lines that intersect, remember, make the X, make the bow tie. All right, make the bow tie. So we have angle IAG. So IAG is congruent to angle NAT, right? So we're going to say angle IAG, angle IAG is congruent to angle NAT. All right. Now, the reason why you have to name that with 3 letters is because this angle in here, you can't just call that angle A. If you call that angle A, you could be talking about a couple different angles. You could be talking about, this angle. You could be talking about this angle, or this angle, or this angle. So you can't just say angle A. That's why you can't do that. You can say angle G, because angle G can only mean one angle. Angle N only means one angle, T or I. But A, you have to be more specific. All right? And we said that these are congruent vertical angles, congruent. And that's enough. We have 2 angles. So we can say that triangle GIA is similar to triangle TNA. And our reason is by angle similarity. Okay, so we have that. All right, let's look at problem number 30. All right, it says in the diagram below, isosceles triangle ABC, AB is congruent to CB, and angle bisectors AD, BF, and CE are drawn and intersect at X. If angle BAC is equal to 50, find the measure of AXC, angle AXC. Now, a couple things, isosceles triangle. What do we know when it's an isosceles triangle? Down here, I have some information you need to write. 2 sides equal length, and the angles opposite those sides are equal. If you have an angle bisector, it's a line that divides an angle into 2 equal angles. All right, so write those things down. All right, now, it says AB is congruent to CB. That means that this side is congruent to this side. That means the opposite angles are also congruent. And let's look at this piece of given information. BAC, that's this angle. That means that is 50 degrees. Now, if that's 50 and AD is an angle bisector, it cuts it in half, which means that this angle down here is 25, and this angle is 25. And we know the opposite angles. The opposite angle is the same. Not opposite angle, the angle opposite. So if these 2 sides are congruent, so I'm talking about this side and this side, that means the opposite angles, which would be this one over here and this one over here, are also congruent or equal. So that means that this entire angle is 50. And that means that each one of those is 25. All right, so 25 and 25. Now I'm just going through and finding all the information that I could find. Now, it says that side BF is a angle bisector, right? So a couple ways you can go here. And let's identify the angle we're looking for also, AXC. So AXC is going to be, let's see here, it's going to be this. That angle, that's what we're looking for. Now, let's go through this and find all the things that we can find. The key is really to know that when you have an angle bisector and you have an isosceles triangle, the fact that BF is an angle bisector means that these are 90-degree angles. Now, we can go through this triangle now and start figuring out more things. We have this triangle here that I'm outlining in blue. Well, if we have two of the angles being 25 and 90, that means this one up here is 65. That means this one over here is 65. And, well, actually, if you just take that angle, those two angles comprise AXC. So if you add them together, 65 plus 65 is equal to 130 degrees. All right? So there you go. Also, another thing you want to talk about. If you knew that these were 50, then you know up here has to be 80. So that means each one of these has to be 40, right? So that's another way you could go. There's so many ways you could go about this, but 130 would be your answer either way. All right?